definition, safety interlock system (SIS) prevents you from making an inappropriate maneuver or adjust the system to a safe state if you make an inappropriate maneuver. What is safety interlock system? Safety interlock switches are used as interlock device that can prevent machine operation or startup in unsafe situations, such as when a door or guard is open. Interlock device with a locking function can also prevent doors or guards from being opened while the machine is in operation.
For the type of SIS, SIS is a method for control of a system and prevent undesirable actions. There are two main types of interlocks system, which is safe and non-safe, and there are three types of interlocks, which is mechanical, electrical, and logical. For the safety interlock system, the safety interlock shows how a programming instruction looks. These interlocks prevent people or things from receiving harm while the machine is running. As for the non-safe interlock, the other type of main interlock is a non-safe interlock. These are used to protect equipment or unintended operations. As for the mechanical interlock, a mechanical interlock is an interlock that is physically connected to another device to prevent unintended actions. For the electrical interlock, an electrical interlock is an interlock that is used to restrict current flow between two or more devices. These types of interlocks use normally open and normally closed contacts to prevent another device from turning on. And lastly, for logic interlock, a logical interlock has an instruction or variable which has to be true to allow a result. The logical interlocks are useful when the devices are not easily connected electrically or mechanically. Thank you.
SCADA. SCADA. Definition of SCADA. SCADA, or as known as Supervisory Control and Data Acquisition, is a category of software applications for controlling industrial processes, which is the gathering of data in real time from remote locations in order to control equipment and condition. How do SCADA system works? Supervisory Control and Data Acquisition (SCADA) is a system that aims to monitor and control field devices at your remote sites. SCADA systems are critical as it helps maintain efficiency by collecting and processing real-time data. The main goal of this supervisory system is to monitor and control equipment in the industrial processes for companies in the public and private sector. As a matter of fact, in today's world, there's a SCADA system almost everywhere. This includes industrial plants, manufacturing, transportation, oil and gas, power distribution, water control, and others. Let's dive deeper into SCADA function and the component that makes SCADA operation possible. 4 SCADA function. The first one is data acquisition. The collection of SCADA's data frequently involves some kind of analog to digital conversion. Temperature is converted to degrees Celsius, transmit signal strength is converted to dBm, channel quality is measured in error second. Second, network data communication. The collected data is transmitted either spontaneously or in response to a request for data to some kind of upstream, consolidator, or master. The communication channel can be analog T202 or POTS or digital RS485 or TCP/IP. SCADA network topology typically also includes some kind of transport validation independent of any content validation. Third one is data presentation. The collected data is processed, organized, and presented for system operators to make appropriate response and control decisions. The presentation can vary from tabular presentation of log even to graphical presentation against mapping or image background. The last one is the control. If control decisions are warranted and the system supports output, appropriate commands can be dispatched to affect specific operational or configuration change. Most control actions are performed by RTOS and PLCs. The four main components of SCADA. The first one is input. Inputs, either digital or analog, and output relays or electrical signals that directly interface with managed elements in the remote sites. That's where the SCADA function starts. These sensor and control relays perform the data equation but can't interpret communication protocols on their own. But your SCADA system still needs a way to collect this data and report it to you in a meaningful way. That's where RTUS come into play. Second one is RTUS, or we call it Remote Telemetry Units. Just like Programmable Logic Controller (PLC), RTUS are small computerized units deployed in the field at specific sites and locations. Remote Telemetry Units, also known as a Remote Terminal Units (RTU), serve as local collection points for gathering reports from sensors and delivering commands to control relays. Third one is a HMI, or as known as Human Machine Interface. HMI software is a computer master station system that processes data and allows a human operator to manage and control the system. HMIS provides the human operator with information gathered from multiple RTUS. This information is displayed in the master unit's user interface that should be understandable and actionable, since quick response action to alarms are usually required. The best HMI SCADA software will present the data as an intuitive graphical representation based on maps. And the last one is Communication Network, CN. The Communication Network is what connects telemetry and SCADA at your remote sites. Today, one of the most common communication technology is Internet.
Okay, my name is Christian Islam Anabita with my metric number 05 DPE 20F 2015. So now I will explain the type of SCADA. So there is a four type of SCADA. First generation is a monolithic or early SCADA system. Second generation is distributed SCADA system. Third generation, networked SCADA system, and fourth generation, Internet of Things technology SCADA system. So for the first generation, monolithic SCADA system. So in early time, during the first time of first generation, monolithic SCADA system were developed wherein the common networked service were not available. Hence, these are independent systems without having any connectivity to other systems. So this is the diagram of the monolithic SCADA system. So we can see that SCADA master connect to the remote terminal unit using the wide area network. Second generation distributed SCADA system. So the sharing of control function is distributed across the multiple systems connected to each other using the local area network. Hence, this was termed as the distributed SCADA system. These individual stations were used to share real-time information and command processing for performing control tasks to trip the alarm level of possible problems. So the size and the cost of the station is reduced, and then the network protocol are still not standardized in the distributed SCADA system. So this is the diagram of the distributed SCADA system, and then we can see that the operating station and communication server is connected through the local area network before the communication server connected to the remote terminal unit. Third generation, networked SCADA system. So generally, networked and communicated using wide area network system over data line or phone. This system use Ethernet or fiber optic connection for transmitting data between the nodes frequently. This third generation SCADA system use programmable logic controller (PLC) for monitoring and adjusting the routing flagging operator only in case of major decision requirement. So this is the diagram of the third generation SCADA system. So we can see that SCADA master connected to the communication server or to the remote terminal unit using the wide area network. Okay, lastly, Internet of Things, which is the fourth generation SCADA. So in the Internet of Things, the infrastructure cost of the SCADA system is reduced by adopting the Internet of Things technology with the commercially available cloud computing. The maintenance and integration is also very easy for the fourth generation compared to the earlier SCADA system. So the Internet of Things also able to report report state in real time by using the horizontal scale from the cloud computing facility. And then the security risk can be suppressed using the open network protocols, such as a TLS inherent in the Internet of Things, which will provide comprehensible and manageable security boundary. Okay, so this is the diagram of the Internet of Things SCADA, and we can see that it have a lot of component in it because of the Internet of Things is a better version of the SCADA that used widely in the industry right now. So this is all from our group. Thank you.